Welcome to Open Source Spotlight.
Okay.
We invite open source authors and ask them to show the tools that they are working on. And today we have Glenn. Hi, Glenn.
Hi, Alexi. How are you doing?
Good. So tell us a few words about yourself and about the tool you want to show us.
Okay. So my name is Glenn Jocher. I'm best known as the author of YOLOv8, which I wrote about 2.5 years ago. And that was part of a startup that I have called Ultralytics. I'm also the founder there. We're a pretty small group. We're a little about under 10 people, mostly in Europe and the United States. And Ultralytics started doing particle physics, and we really found our stride doing AI, and most recently vision AI. And so we've been working really hard on the latest YOLO models for detection, segmentation, classification. And those have gotten pretty popular. And those are all open source on GitHub on the Ultralytics YOLOv8 repository.
What does YOLO stand for? You live only once?
That's a good question. Most people would say that. I think I would say that too. But the original YOLO author, Joseph, took a spin on it, and he called it You Only Look Once, because the architectures of the day did two passes through the images. First to find things, and then to classify what those things were. And so he came out with a major advance, which was just a single pass. And he called that YOLO. And he changed the live for look. So you only look once.
And where does the name Ultralytics come from?
Oh, that's a great question. So when you're starting a company, it's kind of challenging finding a name for it because everybody's already taken all the names out there. So you have to get creative. And it's really just a combination of two things. I was talking to one of the physics professors that I was working with, and I was brainstorming names, and he came out with Ultra Analytics. And I thought, maybe I just put these two together and call it Ultralytics. And I found out that the URL had already been bought. But I managed to buy it from that guy since they weren't using it, and that was how it came out. So,
okay, nice story. Okay, so what do you want to show us?
Okay, all right. So YOLOv8 has been working really well for the last couple of years, but we've been working on something, a secret project for the last few months here at Ultralytics, and it's going to be called YOLOv8, and it's launching January 10th, very soon here. So I'm really excited about it, and wanted to share a few things. So
it's V8.
I am.
So you had V5 and then it's V8. So where are the 6 and 7?
That's a good question. So YOLO actually doesn't quite belong to anybody. So the original author, it was a pair of researchers, Joseph Redman and Ali Farhadi. They split ways after they released the first 3 versions. Ali went to Apple, where he works now. And Joseph decided to go back into teaching, and he wanted to get out of AI in general because he had concerns about the potential use of the technology by malevolent actors, possibly like militaries and things like that. And so he didn't really want to contribute to those possibilities. But he'd released the first 3, YOLOv1, 2, and 3, which are very popular, very powerful. And a lot of different groups picked up from there. And I was one of the people that started working on porting over his work from C, which was in Darknet, to PyTorch. And I worked with a couple other researchers. One of them is very well known. His name is also Alexi. His name is Alexi8, his GitHub handle. And he worked on a version called YOLOv4, which he launched a little over 2.5 years ago. And I released something shortly after, which was called YOLOv5, which baked in a lot of those improvements and tried to make it a little easier to use. And then most recently, V6 was launched by a Chinese company called Meituan. Meituan's a pretty big public listed company. I think they're traded in Hong Kong, and they do things like delivery bots and drones. And so they put in YOLO AI to detect things. So they don't run over pedestrians when a little delivery bot is like crossing on the sidewalk. And then recently, Alexi came back with a much improved version of YOLO, which is called YOLOv7. And he also added support for some additional tasks like segmentation. And we'd seen all these developments going on, and we wanted to bake in all the improvements that the different research groups have been doing around the world. Not just these, but also other versions of YOLO. So there's one called YOLO8 by Mejvi, which is another Chinese company, which is very popular. And they had really good innovations with things like split heads, closing mosaic augmentation for the last few epochs. And there's, of course, Baidu, which maintains the paddle repository. And so they have a version called PP YOLOe. So there's a bunch of different YOLOs now. And
I see.
it may be kind of hard to keep track. Ours is the most popular though. So like Ultralytics YOLOv8 has maintained its popularity. And I think this is because of its simplicity. So when you go to the V5 repository, it's full of documentation. It's very simple to use, and we're really inviting to contributors. And so we have a big sense of community with over 300 people that have helped contribute to YOLOv8, not just our team here at Ultralytics. And I think this is one of the main reasons for the popularity, the simplicity, the ease of use, the documentation. But we could always do better. And so we've taken a look at what everyone else is doing, and we've been working on a new private repository. This repository is right now Ultralytics/Ultralytics, and we're open sourcing this on January 10th. And this is where we've been doing YOLOv8 R&D. So right now we have two things that we can show you here. We have some documentation that we put together. So with YOLOv8, one of the main criticisms was, well, there were two. Like, first of all, we didn't publish an academic paper. And the second is that the documentation was not substantial, not sufficient, they're both valid criticisms, and we took those to heart. And we are addressing both of those pain points with YOLOv8. So we're gonna have an academic paper at launch that explains everything that we've done, plots and charts and comparison metrics. And also we have great docs. And so what we see here is the YOLOv8 docs. And these are maintained at docs.ultralytics.com. They have links right here to a few different notebooks so you can get started really easily. Colab notebook is the most popular, but we also have a Kaggle notebook and a Paperspace gradient notebook. So we've got really easy quick start examples, and I'm going to walk you through those right now on our Colab notebook. We've also got like a nice little write-up of YOLO here. So we've got a brief history, how we came to be, and the new YOLOv8, and we explain all about it. So if we click this Colab notebook link, this will take you to the easiest way to get started here. So this is our Colab notebook. Okay, so the easiest way to get started, and one of the main advancements that we have with YOLOv8 is it's now a pip package. So what we see here is the current installation instructions, but once this is released publicly, we're simply going to do pip install Ultralytics. And this is a big improvement over YOLOv8. Another one of the criticisms that we've had with YOLOv8, there's a lot with the big user base, people find things that they'd like to improve. And one of the main things that people would like is a pip package installation, something very simple. And we've created YOLOv8 from the ground up to be pip package native, and this is the recommended way to install it. So you would simply run this, and this would install everything that you need. If you don't have Torch or the other dependencies, that will install that also. So let me run this right now. So in the meantime, we have a test PyPy deployment, and we're going to run this cell. So this Colab notebook is connecting right here. You can see in the top right to a hardware backend, and then it's going to run this pip install cell. And since Colab includes most of the dependencies, this is pretty short. It mainly installs the Ultralytics package and a few other small packages. And then after that, it's going to run what's called a check, which is going to look at your hardware, and it's going to let you know what sort of resources you're working with to train models. Because as we know, AI models take resources to train. So here we're on the free Colab notebook. So we've got 2 CPUs, 13 gigabytes of RAM, some hard drive space. So YOLOv8 is going to be supported from Python 3.7 up until the current version, and it's going to work on all operating systems. Okay, so now we're installed, and now we can start doing some very simple commands. So the easiest way to get started with YOLO is the command line interface. And once you install the Ultralytics package, you get access to this YOLO command, which makes things very simple. You can run this anywhere in your environment, and you can immediately get started. So YOLO is divided up into different tasks, which are things like detecting, segmenting, and classifying, and then different modes. And modes are things like predicting, training, validating, and exporting. So these are the 2 fundamental arguments for every command. So here we're going to run a prediction with a YOLOv8 N model. So YOLOv8 has come in 5 flavors for most of 2022 and this year also. And it's just different sizes. So we have N for nano, S for small, M for medium, L for large, X for extra large. And this covers a wide array of use cases. The most popular model is the N model because you get very good performance. With YOLOv8, we get about 37 AP 50 to 95 on the COCO dataset, which is the highest ever for a model of this size. It's only 3 megabytes. So we pass a confidence level and a source. And so here you can pass a variety of sources. The cool thing here is we were pointing to a web image. You can also point to local videos, YouTube sources, webcams, RTSP streams. It's very robust. And you can see more information about that in the docs. But so we run this, it downloads the image and it downloads the model. So none of these exist locally. It's downloading them on demand from the latest release assets. It's fusing the model, which means that it's combining batch norm layers with convolutions, and then it's running it on the image. And we can see that we've seen 2 persons, 1 tie, and it's taking 14 milliseconds here on this free T4 GPU that we have on Colab. And it places all the results in a local runs directory. So if we go over here and we look at the runs directory, we can see that it's created these, and it's created an example of the image that's annotated here. So everything's super simple. Just for this one command, we've done a lot of different things. We've downloaded the latest YOLOv8 N model. We've downloaded a web asset, which is this picture. We've run inference on it. We've plotted those annotations. We've created a directory and saved that file here. And this is really just 2 lines of code. Just pip install Ultralytics and then run a prediction. So again, just super simple to use. That's our main philosophy. Because we think AI has got tremendous potential, but it's too complicated at the moment, I think, to realize that. And we're trying to just bring that within reach of everybody that wants to use this, whether it's like in an app or in a project or for startups or very large enterprises too. So the second main thing that you want to do is validate. So once you've trained a model, you can independently validate that model on a data set. So these YOLOv8 models are trained on the COCO dataset for detection. They're trained on the COCO dataset for segmentation, and then they're trained on ImageNet for classification. So this is the detection model, and we can validate this on a very small toy dataset, which we call COCO 128, which stands for the first 128 images of COCO. So that's it. We run this one line. We just changed mode from predict, which we had above, to val. And now we can see all our results here. We can see this broken down by class, and we can see these metrics such as map 50 to 95, map 50, precision, and recall, and how many instances of each class occur in this data set. Of course, people mostly want to train models too. We make that also very easy. We integrate with a number of popular tools, logging tools like ClearML and Comet, data sets like RoboFlow, which are really useful for getting started. And actually, in most cases, you can go and find an existing data set for your use case rather than having to create one from scratch, which really lowers the barrier to entry. So let me see. Let me close this. Okay. So training again is very simple. We change our mode from val to train. We point to a model that we want to start from. So starting from a pre-trained model is always highly recommended for better results. We point to the data set that we want. And here we're just going to train for 3 epochs at an image size of 640 pixels. So that's all this command is. And again, we just hit this play button and we'll train this model for 3 epochs. And the amazing thing is this is a live demo, obviously. And this is going to finish here just within a few seconds. So it's pulled up the data set, it started training, and it's going to begin epoch 1 right here. And since this is a very small data set, 128 images, you can see it finished the first epoch, trained it, it validated the first epoch, moving on to the second epoch, and within just a few seconds here, it'll be done. So I'm going to keep scrolling down here to the export section while that finishes. So exporting is the 4th main thing that we make very simple, and this sort of completes the 4 primary tasks that someone would want to do with an AI model. We support a myriad of export formats. So natively, of course, we're in PyTorch. Oops, let me click out of that. But once you trained a PyTorch model, chances are that you're going to want to use that in a different format somewhere else. Like, for example, if you have a iOS app that you're interested in deploying, you probably want to export that to CoreML to use inside your app. I'm gonna stop clicking on that box. If you want to make Android apps, then you're probably interested in a TF-late export and so on. So we integrate with all of these other formats. I think there's like 11 or 12 in total to make it super easy to take your trained YOLOv8 model. For example, this one just finished training above. Of course, this is a demo. In real life, we would recommend significantly longer training for best results. But once you're done training, the steps to export that are very simple. So here we're going to export an official model. So we simply put YOLO into export mode. We point to the model we want to export, and we tell it the format that we would like. So here we have torch script. So I'm going to play this cell. And since we already auto downloaded this file earlier, it already has it. It's exported to torch script and tells us where it is and some usage that we can do with it, like predicting and validating. And this is the other amazing part. With YOLOv8, you can run inference on any of these exported formats also. So for example, a really popular use case is exporting to TensorRT and then running that on a GPU backend. So this will speed up your inference significantly. And if you have a CPU deployment, you probably want to export to Onyx or OpenVINO. So for example, if you want to do Onyx, you just change this from TorchScript to Onyx. You click play again, and it will begin the Onyx export. So if you don't have Onyx installed, it will handle that for you and install any of the requirements that your command needs, which are installed by default to reduce dependencies for other people that don't require these packages. So what we've seen here is that we tried to do an Onyx export. It saw that Onyx was not installed. It went ahead and installed this. It started the export and it successfully completed it, and it tells us how to use it. So we can go ahead and predict with that. We can run validation, so on and so forth. So there's just a tremendous amount of utility in this package, just with very simple command lines. So of course, most people like Python, and this is a Python first package, and we make that super simple to start. And so the Python usage is right here. You can import the YOLO class from Ultralytics, and then from there you can either build a new model. So we use a YAML configuration file to allow people to really build any models they want, not just YOLOv8 models. You can build YOLOv7 models. You can even build other types of architectures like MobileNet or EfficientNet. And if you have a trained model, then you simply pass that. Once you have your model, then you can again do these 4 tasks as methods from that model. So you would do model.train and pass any arguments that you would like here. If you don't pass any arguments, it will use the default arguments in our single configuration YAML. There's only one YAML file with all of the configuration arguments that you need there. So the 4 methods are train, val, predict, and export. And that's pretty much it. We have examples of different tasks. So the 3 main tasks we support are detection, instance segmentation, and classification. And getting started with detection, which is the default, is super simple. Segmentation models are denoted by -seg. And you can use them the same exact way. You would load a segmentation model this way. And we have a toy segmentation data set here that you can get started on. And then you can run prediction on an image, and you'll get a really cool segmentation mask for that image. And classification models are very simple also. They're denoted by -cls. We have these pre-trained models also available. You can get started training on popular classification data sets like ImageNet, MNIST, so on and so forth, CFAR. And then you would run prediction the same way. So we have this unified structure with CLI usage and with Python usage for the different tasks. And export supports all the different tasks. So you can export segmentation models to any of those formats once you're done training. And so I think this is it. This has sort of been a crash course on YOLOv8. I've explained most of the usage here. So there's, I'm sure, a lot of questions that you'll have, and the best resource here is the docs. So again, like in these docs, you can see the quick start examples. You can see the arguments in the default configuration YAML. You can see support for the different tasks. and you can see the documentation for the different classes, functions inside YOLOv8. So I think
that's
that's
pretty cool. Thank you.
yeah, that's my 20-minute elevator speech.
That's a very slow elevator.
Yeah, it's a very tall building.
How many people are working on this?
That's a good question. So within the company, we're almost about 10 people, but the ML engineers that are working on this are mostly 3 people. It's myself. It's let me see the view citation file. Okay, so we've got myself, Glenn Jocher. We've got Yush Charasia, who came on from Weights and Biases earlier in 2022, and we've got a researcher in China also, which is Jing Q. Goes by LQ usually, and his GitHub handle is Laughing Q. So we've together been doing a lot of research. So collecting the latest R&D from our friends out there in the YOLO community, reading all the papers, running the experiments ourselves to try and reproduce, which is always one of the most interesting parts of the work. And then really writing this repository from scratch. So even though we invested so much time with YOLOv8, this is not really a copy of that. This is something that we've created from scratch, which is Python first, pip package native, very simple to use, and really folds all the lessons learned and the best practices that we've learned and the pain points that the users have told us about over the last few years with YOLOv8. So,
and after the release, how can somebody contribute? Do you have like contributing guide? Good first.
that's a great question. People can contribute 2 ways. So the most important for us is critical feedback. So we want to know when people have problems or if they would like to see improvements. And so they can let us know just directly in GitHub issues. They can say, hey, this works well, but it would be easier if I could do this. And that's really informative feedback for us to figure out ways that we can make people's lives easier. And the second, of course, which is even better, is if they want to get their hands dirty with the code. And so we're going to have a contributing guide to explain to them how to do that. But submitting pull requests on GitHub is, of course, the most direct way. And it's tremendously helpful for us. A lot of times people request a lot of feedback or feature updates. And we have a backlog of features that we'd like to work on. But since we have such a small team and we're trying to do so many things, we have to prioritize those. And so if you have a feature, like a killer feature that you've got, that would be a great addition. You know, simply implementing that yourself and submitting a PR is a great way to go and would really help us out.
Mm-hmm. So right now you don't have any good first issues, but once people start using it, create issues on GitHub, you probably will, right?
Yeah, absolutely. We've got on YOLOv8, we have our hands full here. So every day people raise about 20 or 30 issues. And some of them are like bug reports they have to try and reproduce. Some of them are feature requests, but they're very useful. They take a lot of time to go through, but this is actually what I spend most of my day doing. So I've been juggling both tasks. So maintaining YOLOv8, responding to issues there, and also developing YOLOv8 on the side. So I've been putting in a lot of long hours these last few months.
So
but
what
I think
happens?
people are going to love this.
Yeah. What happens after you release it? What are your plans?
That's a good question. Let's see. Our short to medium term plan is to stay very ahead of the pack in terms of the research. So something funny happened with YOLOv8. So most of 2021, I was improving the architecture, improving the results. But then most of 2022, I switched my focus to adding features and writing tutorials. And for most of that time, I was usually working by myself. And so since I was just one person, since I was busy adding features like different export formats and writing tutorials, then I sort of lifted my foot off the gas pedal for the research side. And that allowed like a lot of these competitors to really catch up to us. And now we have a bigger team and we have some more resources, and we really want to maintain the focus on the research side so that we stay ahead of the field. So when YOLOv8 launches, we're going to be hopefully state of the art in a few different metrics, which means that we should be the best real-time model for detection and segmentation. And we want to stay there. We want to keep our a pulse on the community to see what the latest advancements are. We want to try those out, and we want to feed those back in to the architecture as rapidly as possible. So we're going to have periodic updates. We're planning for quarterly updates. So you should see YOLOv8 8.1 at the beginning of Q2 2023. But if we come out with something that improves it before that, then we'll probably release it before that. So we really want to be as responsive as possible, not just to feature requests, but also to the research that's ongoing out there. Since of course this is a huge effort, not just by ourselves, but it's a tremendous effort by the entire AI community, from small researchers to big companies like Meituan. Everybody contributes a little bit, and what we're trying to do is not necessarily like conduct our own research and stay ahead of the field. We do that also, but we want to split that with combining that with the best that we can see out there from the community, which is really important.
Let's see. Do you have any advice for anyone who is watching this?
Oh, yeah, I do have some advice. So this is a very, I'd say I came in from the outside from AI. I used to do, first of all, engineering and then physics before I got into AI. And I think this really helped give me perspective. It gave me sort of the perspective of wanting things to actually work in the real world rather than kind of writing academic papers and having them work, say like in a laboratory environment. And that took a lot of work. So I had to learn everything myself, and it was all a lot of trial and error. And that was, at least for me, the best way that I could learn things. And so I would say if people are interested in getting into the field, I would say just, for example, checking out a notebook, running the cells, changing a few things. That's how, at least for me, like it really helped me learn in practice how models worked, how they reacted to different settings, different changes in the data sets. There's a lot of theory also. I think statistics is really important, but at the end of the day, the theory can only go so far. And since this is an empirical science, a lot of the time, the result of an experiment is simply the answer itself. And so the best way I think to see that is just to get started running small models on small data sets and doing things yourself that way. That's what worked for me.
Yeah, great. Thanks for the advice. Thanks for doing the demo. It was
Yeah, thank
pleasure
you,
having
Alexi.
you here.
Okay, well, thank you. Yeah, it's
And
great. Thank you for having me, and I'm excited to see what 2023 brings for all of us.
yeah, me too. And I'm looking forward to YOLO V. I don't know which next will be 11, 12.
That's it.
So yeah, maybe we'll see in a couple of years. Yeah, thanks for dropping by
We're all
today.
excited. Thank you.